Hello guys, this is my first video for the year 2022 and we are back on CodeWars. So I'll be doing 3 challenges with you guys and I hope you're gonna enjoy them. But before we actually get started, please hit that subscribe button, hit the like button and comment down below. Also, do not forget to hit that notification bell so you get notified every time I drop a new video. Let's get started. So I'll open CodeWars. So here we are on CodeWars. What we're gonna do is so I've bookmarked the challenge is bit counting, valid braces, and find the missing letter. So I'm just gonna open this on their own tabs. So we're gonna start with this one called bit counting. So the details of this challenge goes like, write a function that takes an integer as input and returns the number of bits that are equal to 1 in the binary representation of that number. You can guarantee that the input is non-negative. Example, the binary representation of 1234 or 1234 is this. So the function should return 5 in this case. So this 5 comes from here. If you look at this binary representation, it has 1 5s. 1 2 3 4 5. So it's the sum of these ones. So let's hit train and solve this one. Let me maximize. So we're gonna have a string called bits where we're going to store our remainders, because we are dealing with a decimal value. We're going to divide it to get the quotient to continue until we get to 0. So while n is not equal to 0, we're going to append the remainder on this string. So let's say bits, and we're going to use the modulus operator to either get 1 or 0, right? So we're just going to do something like n modulus 2. So this expression here will either return 1 or 0. And then that's what we're actually looking for. And then to continue, we're just gonna say n is equal to, so since we want to divide n by 2, it might actually return a floating number, but we actually want the quotient, so we need to make sure we pass it to be an integer. We don't want it to be a floating number. Let's use the parseInt function and have n divided by 2, and then we continue. So now we have something like 0 something, because we don't know what is the value we got here. We just assume that maybe our binary representation is this. So we must be able to return some of these ones, which should be 2. What we're gonna do is we can either use the we can use the classic for loop to iterate through this string, or we can just use the spread operator to convert it into an array. So we can use the reduce method, right? So I'll use the reduce method. So I'll just say return and use the spread operator here and go to bits and use the reduce method, which takes a callback. In our callback, we're gonna have an accumulator and the value, and then we're just gonna return, since the bits is an array of string, or is an array that contains strings or characters, we actually need to convert this sum into an integer, and also this value, definitely, because it comes from an array that contains strings, it also means we need to convert it to a string. I mean, we need to convert it to an integer from a string. It's a string, we need to convert it to an integer, right? So yeah, this is actually I hope this is right. Let's test it and see how it goes. Damn, reduce of an empty array with no initial value. Oh, so wait, let's see. All right. So if n is equal to 0, return 0. Test. Boom. We've passed all the tests. So let's submit our solution. Submit. So since we are done with this one, we can move to valid braces, right? So let's move to valid braces. And then here you can check other people's solutions, right? You can check the, oh, some are very, very short, right? You can check other people's solutions. Okay. So let's move to valid braces. So the description here, or the details, says write a function that takes a string of braces and determines if the order of the braces is valid. It should return true if the string is valid and false if it's invalid. This card is similar to, so there is a valid brace card or a challenge, but introduces new characters, brackets, curly braces, thanks to, okay, I believe this the person who created this challenge for the idea. All input strings will be non-empty and will only consist of parentheses, brackets, and curly braces. So we have parentheses, brackets, and curly braces. What is considered valid? A string of braces is considered valid if all braces are matched with the correct brace. So let's look at the examples here. So we have a brace, a parenthesis that is an opening one, and then this one is a closing one. We have the one that is open, and also this one is a closing one. So basically, for every opening brace, we need to have its a closing one. So if here we have this one, so here's a closing one. We have an opening one here. For this one, we have a closing one. This one, this one. And then here this one is invalid because this one does not have a closing one, because this one is a closing one but they are not the same. They are not matching. Also here, this one is opening, this one is opening, but they are not matching. Look at this. We find the closing one before we actually find the closing one for this one. So if we needed to find the closing, what is this one called, a bracket, we needed to find the closing bracket, we needed to find the closing parenthesis before we could find the closing a bracket. So the order is not correct here, and also here for obvious reason we have a parenthesis, and then we have also curly braces, which is incorrect. So let's try it out. Train. Okay, so let's have something. We're gonna have this, this, and this, which are opening, and then we also must have this, this. So the best way to do this is to have a, let me say, opening. In here we're gonna have this. Oh no, I cannot copy. and paste into here. Why is it doing this thing? And close C. And we're gonna have an array. We're gonna have an array where we store the opening parentheses or the curly braces. We're gonna have we're gonna have an array where we store the opening braces. So if we go through this brace and then we find an opening one, we're gonna keep it in the array. So whenever we encounter a closing one, it means the last one we pushed into array must match this one. So if the last opening brace we pushed into array is this one, so whenever we encounter a closing one, should be this one. If it's not this one, it means it's not valid. So let's have an array constant array of opening, right? Let me just say array opening, an empty array, and then we're gonna have a boolean variable which checks whether we had a valid braces or not. But then at the beginning we're just gonna assume that we have valid braces, so we're just gonna say let state equal to true. We just assume that everything is correct or everything is matching. So what we need to do now is to go through these braces, right? Let's do this and check if we are getting a string. So it's a string, so we are iterating. We're gonna go through this string using a for loop. Let I and braces dot length I. So if the opening the opening, no, this one is opening braces. Let's say opening braces so we understand what we're actually dealing with. Let's say we're gonna check in our opening braces using the function called includes. So we're going to check if the brace that we are currently at, because we are going through this brace string. So if we're gonna check if the brace we are currently at is an opening one or a closing one. So if it's an opening one, we're going to push it into our array opening dot push braces. Else if it's a closing one. So whenever it's a closing one, it means it needs to match the last brace we pushed into our array. So let's say closing braces dot includes the braces. But I think they are short as in the description that they're always gonna give us only those braces. They're not gonna give us, but it's okay. We can just use this expression. So this expression checks if this brace here, the brace at this index, is a closing one. If it's a closing one, so we need to do some magic. So if you check here, so if it's a closing one and it's at index 0, for it to be valid, the closing one, the last one that we pushed into an array, must be of index 0. Because if the last one we pushed into the array, it was index 1, it means they are not matching. So this means we no longer have a valid brace. So what we need to do is we need to get the index of the last value we pushed into array and then the index of the value that we currently add. So if we take this value, we can be able to find the index in this closing brace. So we're gonna do this with a method called index of. So say let's closing index closing braces and index of braces at this index, which is I. We also need to find the opening brace that we pushed into array, the last one. So we're gonna use the, let's say, last opening brace by saying array opening, nope, opening dot pop. So this pop function will return the last value we pushed into array, but we still don't have the index of this last value we pushed into our array, right? So we need to find it. Constant, it's an opening index. We're just gonna use the same expression like this one here. We're just gonna say opening braces, actually index of, nope, last opening, because we need to find the index of this one. So if the last one we pushed was this curly one, so it means the index is 1. And then if the closing brace that we are actually at is this one, so it means their index are not the same. Therefore, this is not a valid brace. Therefore, we need to return what? False. So let's say last opening brace. So we need to compare if closing index is not the same as the opening index, then we simply change the state to false. Because remember, we have a state here which keeps track of our whether we have a valid brace. Because let's say we iterate through these braces, but we never have this expression. We never actually get into this block here. So it means our state will remain true. Therefore, we have a valid braces. So whenever this is not true, we actually going to change the state to false. So we actually do not have a matching brace at all. Let's say return state. What am I doing? Wow. So we wrote all this without a test. Let's see how it goes. Let's test it. Let's test. I hope. Oh, oops. This was an interesting one. So let's try to pass all the tests. Oh no. Expected true equal false. Expected true to equal false. Oh yeah, I know what's the problem. We never consider where we only have opening braces. Our code here actually doesn't accommodate for that. Because if you only have opening braces, we're just gonna keep pushing them, and then at the end we're just going to return true, because our initial value here is true. So let's have something that keeps track if our braces have opening and closing, right? Say let have closing, and have closing, we're just gonna say false for now. So we say for now we just assume that we do not have a closing brace. But once this expression is true, it actually means have closing now can actually change to being true. What are we gonna do with this value? We're just going to return them here together because we're gonna have closing. So this expression here will return either true or false. Yeah, let me test it. Let me test. I hope this is better. Oh my god. We have passed it. Great. You may take your time to comment now. We're not commenting for now. Let's submit this one. While it's submitting, let's move to the last one. Wow. So this one is called find the missing letter. Find the missing letter. Write a method that takes an array of consecutive increasing letters as input and that returns the missing letter in the array. Okay, you will always get a valid array. It will always exactly be one letter missing. The length of the array will always be at least 2. The array will always contain letters in only one case. So we won't have an uppercase and lowercase. So A, B, C, D, and E is the missing one between D and F. Oh, so here we have a missing P. All right. I think for this one we are going to use an Ascii table. Yes. So let's hit train. Maximize. So we get an array that has letters, right? So in JavaScript we have methods. So let me explain this. So each and every alphabet or character has a hexadecimal representation on the Ascii table. So all we need to do is convert the numbers, the letters we have in our array to their hexadecimal representation and find the difference between them. So A has its numeric representation. Would just, for example, just gonna say 1, but it's not 1 on the Ascii table. So B has to be what? Has to be 2. So for example, if we had C, here it would be 3. So the difference between A and C is not 1. Therefore, there is a missing character between A and C, right? So yeah, we're just going to use the methods that JavaScript give us. There's a method called character code add, and then there's also one called, there's a method called code add, and then we also have one called from car code. So we're going to use these methods to convert the values from an alphabet to a numeric representation and from the numeric representation to an actual alphabet. Okay, so let's start with our actual code, right? So we're going to use an array to iterate. I mean, we're going to use a for loop to iterate through the array. But we're going to start we're going to start at we're going to start at 1 because we want to compare the value at index 1 and then the value at index 0, and moving forward the one at 1, at 2, and then the one. Let me do this so you can see what I'm actually talking about. I is less than array length. So our current letter is at index what? We are at index I, No, what am I doing? And then we're gonna have the previous letter, which is at I minus 1. Let's say if I had something like this here, I wasn't gonna be able to get the previous letter. The previous letter was gonna be what? I, which is 0 minus 1, is out of bounds. So that's why I'm actually starting at index 1. So now I have two letters at index 0 and index 1. I need to check the difference between them. So constant difference. So to be able to check the difference between them, I need to convert these letters into their numeric representation, right? I'm gonna say current, which is, we have, for example, we have A, B, C, D, E, and it's missing, and we have F. So we have current is 1. So we have B, and then the previous one is A. So we're going to take this one and find the difference between these two, right? So let's go. We're gonna say, so since they said it's a consecutive, it's the letters will be in a consecutive manner. It means A will always come before B. So the difference must be B minus this one, because B will always be greater than A, the previous one. So we're gonna have current letter and use those two methods, current and code add. So this method will return the numeric representation of this letter, and we find the difference between this one, car code add. So since it's in an increasing manner, we'd assume this is 1, would assume this one is 2. So the difference will always be what? Will always be 1. If it's not 1, it means we actually, if it's not 1, it means we actually have a letter that is missing between them. So if difference is not equal to 1, we need to return the letter that is missing, because the difference is not 1. So if the difference is not 1, it means we have a letter that is missing. So what do? We return it. We return that letter. But how do we find that letter? How do we find that letter? We're just going to say previous plus 1. Previous, which is A, plus 1. So for example here, the previous will be what? Between D and F, the difference won't be 1. So we're going to say previous plus 1, or the current minus 1 will put us here. D plus 1 will put us here. F minus 1 will put us here. So we're just going to say previous car code add plus 1. But then previous letter. But then this actually will return the numeric representation of that letter missing. So we're going to use a method called, in this string class, called from car code. So this converts the numeric representation into its alphabetical representation. So whenever we find a difference that is not equal to 1, we convert it from the character code plus 1, so which is previous is D plus 1 is yes. And then if ever we find that all of them were this difference were the same, just gonna return now. Yeah, let's see how this one goes. Oh, on first attempt. Let's check other people's solution. Guys, this is the end of the video, and I hope you enjoyed it. And please do not forget to hit that subscribe button, leave a comment down below on how to improve. Yeah, I think this is the end of the video.